All right, so now we're recording again. This is class number 12, Pkt6, take 2. I was telling them what I was telling them when we got cut off there was that there are 3 new equation sheets, side 13, and you already know about that one, so I'll just move on. Side 14, and then side 15 is a new one, and that's Bernoulli's equation. And we're just going to give it to you for this year. We don't have time really to get into it too much. And then this terminal speed we were talking about before when we got cut off. We were talking about hailstones. Yeah, if we get cut off again, I think if we get cut off again, then I'm just going to have to then maybe hang out for a couple minutes. But then if I don't come back on, just go on about your business, and I'll try and do this when my computer's acting normal. It's got plenty of juice, so I don't know why. Anyway, so we were talking about hailstones, and we were saying that the mass of the hailstone does make a difference. It is the square root of the mass that it goes up by. If you double it, if you go 4 times the mass, the terminal velocity will go up, will double. And so I was thinking 31 miles an hour is probably true for a small hailstone, but the ones we had last night were probably more in the 50 to 60 mile per hour range. And then I was saying that I think David Payne does the best job of local forecasting, because he actually you learn stuff when you watch him. He does little lessons and stuff. It's cool. All right, and then the last thing on here is a thrust equation, and I wanted to point out here what I'm trying to. I went and got that picture of the F-15, and if you notice, there is escaping gas, and this M dot VE refers to the escaping gas. It doesn't refer to the F-15. All right, that F-15 is a reaction force to all that escaping gas. Okay, so the escaping gas goes, in this case, it goes to the left, and then the F-15 then, because of recoil or Newton's third law, which we're going to get into today, goes to the right. All right, but say you're losing, because gas doesn't weigh that much. Say you're losing 1 kilogram a second. That's still 2.2 pounds a second worth of gas, but it's coming out at, say, Mach 2. Well, that's 660 meters a second. So now that gives you a thrust of 660 newtons, which is not enough to keep an F-16 to speed up, but still quite a bit. It's about, for newtons, it's about 1 pound every 4 newtons. So that'd be about, you can about 100 pounds of force pushing you. That mass flow rate from an F-15 must be in the order of 10 kilograms a second, and probably the escape velocity is, if that's at Mach 2, that puts you at pretty high thrust. Okay, so that's new, and you'll get that on the test tomorrow. You'll get all 15 sides. You'll have available to you, which in your case, you would just go off Facebook, and you can, or if you want to print those off, you can. But in class, they get a classroom set. We talked about this a little bit. I got to move through this kind of fast, so we got to get to where we're trying to go today. We were talking about depth, and this came up from the submarine talk, which because of the disaster in Indonesia, where like 60 some odd sailors in a submarine were crushed to death when the submarine was breached. So they're at, look at this, at 33 feet, and I have a student that scuba dives. He said he scuba dives around 50 feet. So barometric pressure, there's all kinds of units. It's probably, of any concept in physics, pressure, I think I can make the case that pressure has more units than any other. Like, force has got pounds, it's got newtons, but pressure's got atmospheres and PSI and kilopascals and torricellis and torrs, all these things that different countries use. So atmosphere is a good one, because right now in this room, I'm experiencing, and I don't know why they say ATA, it's actually ATM. I don't know why. I don't know why they did that, but ATM is normally it. So I'm sitting in this room about 1 atmosphere pressure. And so that's same thing as 14.7 pounds per square inch. If I go down 33 feet in the water, and most people don't do that, how often do you go 33 feet in the water? I mean, a typical swimming pool, I believe Olympic size is what, 10 feet at the drain. So 33 feet, the only way you go to 33 feet down the water is if you scuba dive. So scuba divers, they're going to experience 2 atmospheres, about twice the pressure. And then, so if you're in the 50-foot range, you're about 2.5, 66, 3 atmospheres. So it's kind of nice and easy to remember this. About approximately every 30 feet, you double the amount of pressure on you. So at 99 feet, you're sitting at 4 atmospheres of pressure, 4 times the pressure on you. Another kid said that he scuba dives, but he gets a real headache if he gets past 50 feet. Yeah, so these sailors were at 3,000 feet. So you can only imagine the amount of pressure they experienced. Okay. Yesterday, I tried to, we did this in class, and I tried to show you by my live demonstration, you can go back and watch that if you want, of these wooden vectors. And we're using the wooden vectors to show free body diagrams and head to tail. And so here's 3 of the head to tails they came up with. And so one of these is wrong. I'll let you pick out which one it is, but let's go with this one first. Remember the orange vector represented weight, mg, and that has to point straight down. The red vector there represents summation of forces. That's the resultant, and that points in the direction of motion. The brown vector there represents air drag, and that's always opposite the direction of motion. The white striped one, that one represents lift, and it's always perpendicular to the direction of motion. And then this one is actually one vector. That was sort of your ace in the hole. That's thrust. Thrust can go unless it specifies, it can go in any direction you want and have any length you want. And so you can use thrust to kind of make it work. And so that's one scenario. The thing was, this is an F-15 thrusting, and their engines are firing and accelerating through the atmosphere, our Earth's atmosphere. So I don't see anything wrong with that. Let's go to this one. Maybe this is wrong. Let's take a look. Orange is mg, that's straight down. You don't see the tip on the summation of forces, but that gets covered up by the thrust, but that seems okay. It starts here, and it starts at the very beginning, ends at the very end. The brown is air drag, and that is opposite the motion of force of thrust. Direction of motion, or summation of forces. The black stripe, that is perpendicular to the direction of motion. That's good. And the force of thrust can be any direction at once, as long as it makes it work. And so I don't see anything wrong with that. Now let's go to this one. This one seems okay. mg is down, as it's supposed to. There's your direction of motion, your summation of forces, the red one. The brown one is opposite that direction of motion. The black striped is perpendicular to the direction of motion, and then the thrust finishes it off. So what's wrong with this? It seems right. And I didn't notice it either at first. Anybody see the mistake? Oh no, by your chat, because I can't open up my other screen, I can't see a chat. So the only way to communicate today is to turn on your mic and talk.
Is it because the motion is pointed?
Yeah, pointing the wrong direction. That's what you guys are both saying, I think. So it's pointing the wrong direction. Remember that the summation of forces has to go from the very beginning to the very end. You say, well, that's an easy fix. I just turn the red arrow around. The problem is, if you turn the red arrow around, you got to turn the brown arrow around. Well, that's not easily done. So this whole thing, then, that kind of messes everything up. So that one's just wrong. The next one shows a group that did it this way, and then the same group redid it. And what's missing? This is the free body diagram, and this is head to tail. What's missing from the free body diagram?
your force of thrust?
No, force of thrust is this. It's this one. It's actually 3 vectors. It's all in one vector, but you know, that's the one you could adjust the length. So that's the same as that one. MG is down. That's good. It's got that one. There's the back force. There's the drag. There's the force of lift. Notice that that one is gone. And this one is summation of forces. You don't show on a free body diagram, you don't show summation of forces. Not that it's really wrong, it's just not necessary. It just gets in your way. If you showed it, would I count off? Maybe if it's worth 20 points, I'll take off a point. I mean, just slap on the wrist. But yeah, you don't need summation of forces on a free, just it's not necessary. It is obviously in a head to tail. Okay. Last year, the pandemic was in full effect here. And so we tried to do this just using arrows. I drew a bunch of arrows on my iPad, and then I had them kind of help me manipulate them and move them around. And that's what we got for head to tail. And then I'll put this on the screenshots. Then I explained it over here then I moved them all around just you can just touch them and move them on an iPad. So that's the same thing, this time drawn in a free body style. Okay. This is Maddie's from a couple of years ago. I think she's now a chemistry major at OU. Hopefully she'll still maybe switch over to physics. I'm trying to get her to. But this is how she approached a problem. Same problem. By the way, this problem is on your practice problem. So it's a potential on the test tomorrow. But this is how she would attack it, right? So she goes through and she gets a good drawing there. She figures out what each one is. She starts labeling things. And then she did she could have shown 6 steps, but she did 5 steps there. So she labels her steps. And this is I see her thought process. So you start off with the free body diagram. You go to your F equals MA. What she didn't show you is how she found that force of thrust. And the force of thrust was m dot VE, and the m dot was m dot was 350, the VE was 500, and that's what gave her that 17,000 or 175,000 newtons of thrust. I think these are actual numbers here. This is a real example. I don't know if that's Falcon or not, but and then she showed putting those together, solving for AY, and then she showed to put that into kinematics and finally come up with your final velocity. So that's a great way to show your work. A lot of you guys are really good at showing your work, but that's a good example. I'll post that this afternoon. Okay. Now, there's a video I want to show you, and we watched it in class, and it's one that Ben sent me last night. And every time he does this, he sends me videos that get him points. He's racked up some Facebook points now. He likes to watch YouTube videos and TikTok and stuff anyway. So if he finds one that fits what we're talking about, he puts it on our Facebook group, and I award him up to 15 points. If I show it in class, he gets 15 points. So I'm going to stop this sharing. New share. And we find this guy. I think that's it. Now I'm going to have to. Last time we watched a video together and we recorded it. YouTube went crazy on copyright. So let me pause. So if you're watching at home and you'll see this pause, then we'll come back. I'll put a link to this in the comments. So I'm going to. All right. So if you're watching this, we just watched a 5-minute video. I paused it here and there, but I'll put the link in the comments. If you're looking to get into that, you need to have, I would guess what you want is a mechanical engineering degree. And then probably have to go to one of these schools to become a specialist for this auto design. All right. I gotta skip that. Okay, I want to get to this in the last little bit of time we have. I want to at least start this. We did This is 6.3, and we did this one yesterday in class. And so you got to kind of come up with this on your own as well, come up with your lengths. And then number 2 is a really good one to look at, hint, hint, to prepare. We've worked ones like that. And now let's look at, I want to spend the rest of the time though, and number 3, 3A and B, and let's at least get started on 3. Some that all that delay put us behind. So 3, we're going to finally get into Newton's third law and talk about systems of boxes, systems of objects. And so A is 2 newtons. It's like a box on a box. It seems simple, but it'll bring up some big stuff. So A is 2 newtons, and each one of these little lines here it represents 2 newtons. And then B is 4 newtons. So that's about a pound. 2 newtons, about a half a pound. All right. So we got to draw the free body diagrams. It's 2 things that are connected. So obviously this is, I'll make a mistake here. All right. This is MG. Anybody see my mistake?
Box A is on top of box B. So wouldn't box B have the MG?
Box B does have an MG. So box B, since you said that, box B, I haven't, come on, man. Get off that. Box B, it is 4 newtons. Each one of these little lines is 2 newtons. So box B has an MG. You see my mistake now?
Wouldn't box B be the only one that has the MG?
Nope. They're both attracted to the Earth. They both have mass. They're both attracted to the Earth. So that's not the problem. The problem is the way I wrote it. How do I know which M is M? Which M is it? So I got it. If there's more than one body involved, you have to say M sub A G, M sub B G. You have to show. You have to distinguish. Okay. Now, what are the forces on A? Well, we have normal force, right? And I just made another mistake. Those are congruent because that mistake won't come clear until we go down here to B. B then has 2 more forces on it. What's one of those forces?
Would one of the forces be the weight of box A?
Right. And so that's true. And so you put this down, and that is, oh, my bad. It's only 2 newtons. So that is, and the way I show that is I make that N again. It's because it's a contact force. And then B is sitting on a table. Let's assume there's a table down there. So I have, and that's going to be now 6 newtons, which is 3 lines up. And that is in. Now do you see my mistake? Or not my mistake, my omission? What did I fail to do?
Does N have to have the
subscript? Right. So you have to have subscript. Well, you can't say in on this one, you can't say N sub A because it can't be the body itself. So you say in the source is B, N sub B. This N sub A, and this is N sub T. So now all we have to have all these subscripts when we have these, 3 or 4 bodies in one system. And so that's also congruent there. Now we're right at the point where we got to learn Newton's third law and show how it's applied, but we are at 2 o'clock now. So we're a little behind. We'll have to play some catch up on Monday. They'll have joke Monday, so we can catch up then. So don't worry about, well, yeah, I would go ahead. You will need to have this sheet done, 1, 2, and 3. But don't worry about 3 yet. We'll come back and do 3A and B, but I think you can do 1 and 2. Okay. So apologize for all the, I'm going to go spend $2,000 and buy me another laptop and another iPad. Make that $3,000. Anyway, we would think the school would buy it for me. No. All right. So I will see you guys. Oh, now tomorrow we're not gonna meet tomorrow. You're going to see an email from me by 2 o'clock, around 2-ish. You'll see an email that includes the test. Now it won't include the equation sheets, but because I tried that. Remember, I tried that on 4B, and it wouldn't even send to half of you because it was too big a file. So I'm just sending you this 2-page, 2-sided test. Might as well tell you that. So you're gonna print it off or put it on your iPad, take it, and then what did I say? Where did we leave it at? It's best if you can get it on my porch so I can actually go through and write all over it and make notes. If that's physically impossible for you, you can submit it by these are all due by Saturday at 6 o'clock p.m. no matter how you turn it in. The latest Saturday 6 p.m. either on my porch or submitting it. And if you submit it, though, I'm not going to be able to tell you. I'm just going to say you got on number 4, you missed 7 points out of say 20. You go, I don't know why I missed it. Well, because I can't mark it up. That's why I need to have the paper with me. Anyway, so submit it, and then you can still do blue that way. And so really, I think I concluded last time that maybe submitting it because of the blue problem, because if you turn it into my porch, I can mark it all up, but then you still don't see it. Then how are you going to know how much? So maybe your best bet is just to submit it. I hate to do it, and then when you look at the key, you can go, oh, I think, and you'll have your paper with you. You can compare your paper, the physical paper you still have, to the key. Then you go, okay, I can see why he would take off 7 here. Maybe that's the best bet. So maybe I'm changing my mind. Maybe not, because of the blue issue, maybe not turn it into the porch. Maybe just submit it. And then I'll go through and tell you how much you missed on each in a message. Does that make sense? Thumbs up. Okay, so I will. You're free to go. If you want to stick around and ask a question, I'll stay here until I've answered all your questions. So I'll see you guys. Won't see you till Monday.